All right. So in our first box, we're going to describe what is a complex number plane. Well, basically, when you are dealing with a complex number, that's your a plus bi, right? And so when you're plotting the point, your point is simply your a, comma, your b. What is the value of your a? What's the value of your b? Okay? And that, again, comes from your complex number, which is a plus bi. Maybe what I highlight? I don't know. What do you feel like you need? Locate. So first, the real part, which is your a, the real, you're going to count on your horizontal axis. And the imaginary part, that is on your vertical axis. So what that's saying, you two know you can always sit right there if you are having a hard time seeing. So what that's saying, here's my horizontal axis. This is where I'm going to count my reals at, my a value. In case we didn't know which way the horizontal went. And then it says vertical axis. This is where we're going to count our imaginary piece, our b values are at. Okay? When you're plotting something, they come together. So I'm going to go just as if you were plotting regular coordinate planes. You're going to go left or right, up and down. Where they meet is your point. Okay? Next is your absolute value of the complex number. And that's absolute value just means distance. And the distance we're looking for is how far is it from the origin. Okay? How far is the value from the origin? And to calculate that, it is the square root of a squared plus b squared. And that is it. So again, plotting, your reals are horizontal axis. Your imaginaries are your vertical axis. Absolute value is your distance from the origin. And that's the square root of a squared plus b squared. Now, for my ones who are trying to write every single thing on this board, I'm going to let you know we're about to change slides. You're going to need to go to Google Classroom if you feel like you need every single word on here. Okay? We're preparing for when you're in a college course and you should have gone to your Brightspace or your Blackboard or your Canvas prior to class, pre-written those notes, and been prepared. So, if you're a person who needs to write every single detail in a pretty font and change your colors. Let's do it. So, box 2. Our example 1. We have -5 plus 3i. So we're going to graph. So you're going to draw a little sketchy sketch. And we're going to find the absolute value. Step 1 is to identify what's your a and what's your b. So step 1 is what's my a? -5. And what's my b?
3i.
Not 3i, just the 3. The I is just there. The b is just the number.
That's all one step.
Identify your variable. Step 2 is to actually graph them. So remembering that your reals are your horizontal and your imaginaries are your vertical. So on my real, I'm going to -5. -5. Is that to the left or to the right?
Left.
To the left. So I'm going to go 1, 2, 3, 4, 5. From my real, I'm going to go to my imaginary. I have a +3. Is that up or down? Up. In case y'all are wondering.
Yay! Thank you.
And here is -5 plus 3. There's the point.
We did it.
We did it. It was so hard.
Actually? I always thought I was like
So step 2 was the plot. Okay. Next it says, what is the value of your absolute value? What is your absolute value of the number? So absolute value is asking us how far is it from the origin. That's what it's asking us. What shape did I make here?
Triangle.
Oh my gosh. What kind of triangle?
Right.
Oh my gosh, a right triangle. In this place called geometry, did we learn how to find the missing side of a right triangle?
Yeah.
Yes.
What is it called?
Pythagorean
The
theorem.
Pythagorean theorem.
A squared plus B squared equals set 5.
OMG, mind blown. Okay? So, I wonder why the absolute value of a plus bi equals the square root of a squared plus b squared.
Whoa.
Because I'm looking for the hypotenuse of my right triangle.
That's great.
Isn't that crazy? Geometry, algebra 2, they go together. Who knew?
Like birds of a feather.
Okay. So, that's why this comes. This is why this exists, because what did I create? A right triangle. Okay? So when I plug these values in, what was our A?
-5.
-5. So we have -5 squared. And what was our B?
3.
And we have 3 squared. What is -5 squared? 25.
Okay.
Plus 9.
And 3 squared is?
9.
And that gives us what?
34.
34. Can I break that down? Can I simplify that?
Yes.
To 2 and 17.
Well, technically.
Those are primes. So can it be broken down?
No.
No. So my answer is just?
The square root of 34.
So my absolute value, my distance to the origin is square root of 34.
Whoa.
That's a pretty big number for those.
You are. You're going to do 2 of them by yourself. Don't even worry. All right. Yes. No. Maybe so. Was it terrible?
No.
No.
Yeah, that.
Okay.
Okay.
All right. Here's one for you to try. Example 2. 6i. Hit it.
Oh, I thought it was
We don't just like look at
just
it.
6i.
Copy the graph.
I actually grabbed it.
Oh, yeah.
Just like
No. It's example 2.
So then you would do that, and then it would just go. Just, that's it?
There's nothing there. We're seeing people's level of common sense right now.
Oh, what's it? Somewhere.
Wait, is that example 2 or is that 2 like?
It's example 2.
Example 2. So it's just 6i.
It's just 6i. All right. I feel like we've had enough time to do this one. If you're just now getting your mind together and deciding to do it, that's a different thing. But you've had time to do it. So step 1 is identify your variables. If there is no a present, what does a equal? 0. I literally said example 2. 6i.
I know. I'm talking about, I thought there was those.
No, what is the 6? It's my B. Okay? So, identify, and I'm going to graph. So, I come over here, my real, my imaginary. I'm not going left or right anything. I'm only going up 6. So, 1, 2, 3, 4, 5, 6. And I plot it 6i right there for you. That's it.
that's it.
And then, absolute value of this lovely 6i. How far is this from the origin?
6.
6.
That's the
That's the answer.
Whoa, that's
There
crazy.
was nothing else. Could you have gone through and did 6 squared and got 36 and then said square root of 36 is 6?
6.
Yeah, you could have gone around the whole mulberry bush. But our hope is that
You could just do that.
you could have just counted because you just had to get back to the origin.
Wow.
Right? Yes?
Yeah.
All right. Next one. Last one for you to do. Example 3.
What you doing, Toes?
I don't know.
Go.
Made it very late.
Example whoop.
Wait, so the first period is the example one?
Yeah, they've been at me.
They're special.
You have 5 minus I.
Okay, so my brother, one thing that we're gonna be around here.
Identify your A and your B.
I've been asking myself.
Graph and find the absolute value.
Don't say that. No,
So funny.
you.
All right, ready, Freddie?
No.
What's my I? My A?
5.
5. So we have A equals 5. And what's my B? Negative 1. My B is negative 1. So when I come over here to graph, I have my real, I have my imaginary. So I'm going to go to 5. 1, 2, 3, 4, 5. And I'm going to go down 1. And this is where 5 minus I is. So next it wants to find what is the absolute value of the number. So it's asking how far is it from the origin. So I'm looking for how far is it from the origin. So I'm going to take the square root of 5 squared plus negative 1 squared. And that gives me what?
26.
25 plus 1. And that equals?
26.
Can I reduce that in any form?
No.
What? It's 36.